Hey there! Today, I'm going to show you a fascinating project I worked on with my team for my cybersecurity module. But first, let's kick things off with a bit of history. If you have never heard of Ken Thompson, you should at least know that he's one of the inventors of Unix. And in a famous lecture of his called Reflections on Trust and Trust, Ken demonstrated how a compiler could be compromised to insert malicious code into every program it compiles. And today, we're going to implement a variation of this problem where the injected code would be part of a reverse shell attack and the code injection would be done using a different approach. Stay here to dive into how we created this malicious GCC compiler that can inject a backdoor into your C programs. Our initial plan was to modify the actual GCC source code to inject our backdoor. But we dived into the deep end, trying to understand the complex GCC code base, especially the optimization phase. But guess what? It was way over our heads. So we reached out for help, and here are some screenshots of our desperate attempt on Stack Overflow. And as you can see, it became clear that this approach was too advanced for our current skills. So we changed to a simpler yet effective solution. And the solution was, as you probably would have guessed, as it is a naive and natural simple solution, was the GCC wrapper. And now, instead of altering the GCC internals, we just wrote a Python script that wraps around the GCC compiler. The script preprocesses the source files we need to compile, injects the backdoor in them, and then calls the real GCC compiler to do the actual job of compilation. And let me show you exactly how it works with code. Well, not to get things messy, we divided the project into two parts, the attack and the code injector. To handle errors better, and at the end, we have to merge the two parts by using the code of the victim and the attack as the injected code by the wrapper. First, here's how the wrapper works. It takes the same file names and arguments passed to the compromised GCC, and since the code should be injected into every C program, we ensured it's only added to files containing the main function to guarantee it's executed every time the program runs. By checking first for the main file using regex. If it is the main file, it is copied into a temporary file where the code is injected in the original code. And then this same file is passed to the actual GCC compiler. But if it's not, the file is directly passed along with its arguments and parameters to the actual GCC. And we made sure that this addition of the code won't affect the original functionality of the C file. And we also made sure that our new compiler could handle all kinds of commands and arguments that a typical GCC would, including multiple files, compilation, arguments, and library calls at linking time. And after extensive testing with various scenarios, we confirmed it works perfectly. For an example, we started simple, and the wrapper initially injected a print statement saying code injected. The code obviously uses regex to spot the different code sections in a C file, like the library calls, the constant definitions, and the function definitions, and finally the main function call, to inject the code appropriately. Now let's try to compile a simple Hello World C program and check for the injection of the code. And yeah, it works just fine. And now we go to the attack part, where we inspect two main files. The attacker script, where it opens a TCP port for listening for incoming connections, and the victim script that connects to that port on that server and handles shell commands execution in its machine environment. Takes them as text input from the attacker, processes them, execute them, and then forwards the standard output and error to the attacker. The script uses system libraries special to Windows, what makes our compromised compiler compatible only with Windows systems. And the attacker script simply inputs the commands as text and sends them to the victim to execute them, and have the choice also to open a new shell session or to exit the session. Now let's see the attack in function and try some commands. And yeah, it works fine too. Now we combine the two parts into the final product. We make the wrapper as an executable using PyInstaller, rename it GCCC, and it stands for GCC Compromise, and finally put it in the bin of the actual GCC folder to make it easier to call the original compiler. And this is the result. The wrapper code now injects the code of the victim script that was in C language in every C program it compiles. And the program, when run, starts the reverse shell with the attacker's servers. Let's compile the hello world again using the GCCC and see the results. But we should start the attacker port first. Now we run the resultant executable, and yeah, it works and the connection is established just as before. And yeah, this was all about compromising GCC to perform reverse shell attack using the wrapper method. For final word, I have to say that this project ties into a broader lecture about software integrity and why the integrity of software requires the integrity of the build tools and OS used to build it. This project is a stark reminder of why we need to trust our development tools. Stay secure, and thanks for watching.